much weight can you lift on the different planets? Imagine being able to lift a motorcycle with one hand or making a 32-foot or 10-meter jump using only your legs as thrusters. Although they appear like powers befitting of a superhero on other planets in the solar system, all these incredible feats would be attainable for humans. Do you want to know how? Let's begin. Everyday activities such as moving a chair to sit on, lifting goods and bringing them to another location, and even moving with our feet include lifting and carrying stuff. Sometimes we run into the difficult task of having to lift weighty objects like the furniture in the house and wonder if there would not be an easier way to do it. Although there are undoubtedly simpler methods than relying solely on our power to move a piece of furniture, what if we were able to lift anything, without the need to use cranes, ropes, or any other tool? Without exerting excessive effort, a healthy adult can lift between 44 and 66 pounds, or 20 to 30 kilograms. But what if a human tried to lift that same weight on the moon? The moon is the only natural satellite of our planet. It is smaller, therefore, it has less mass, and because of that, its gravitational pull force is weaker than on Earth. In other words, a person weighing 110 pounds or 50 kilograms on Earth will weigh as little as 18.7 pounds or 8.15 kilograms on the moon, only 1/5 of what they weigh on Earth. Thanks to this, an average person on the moon could lift a 330 pounds or 150 kilograms motorcycle without any problems with one hand. Because of this, leaving the moon only requires small rockets to provide an initial boost, as opposed to leaving the Earth, which requires enormous rockets. As a result, the men who traveled to the moon were able to return to Earth on board the takeoff module, which had provided them with the boost they needed to escape the moon's weak gravitational pull. This phenomenon arises because the weight of objects depends on two things: on the one hand, mass, and on the other, the force of gravitational attraction. The more mass an object possesses, the greater its weight. However, the weight can also grow if the force of gravitational pull increases. On Earth, for instance, the gravitational acceleration force is 9.81 meters per square second. On the other planets, this gravitational attraction force varies. Thanks to that, things weigh differently on each planet. Do you want to know how much you would weigh and how much you could lift on each planet? Let's start with Mercury, the closest planet to the Sun. Mercury has the weakest gravitational pull of any planet, with a force of gravity of only 3.7 meters per square second. An adult weighing 150 pounds or 68 kilograms on Earth would weigh as low as 56.4 pounds or 25.6 kilograms in Mercury. Because of this, if we could walk on the surface of Mercury, we would feel exceedingly light. Since our body would lift slightly with each step, losing contact with the ground and tipping our center of gravity off balance, walking would be challenging for us. Much like astronauts who went to the moon, the people who go to Mercury would also have to walk taking little hops. An additional fact is that while a typical human can jump 1.6 feet or 0.5 meters on Earth, we could jump up to 3.9 feet on Mercury or 1.2 meter. On Mercury, an untrained adult could lift objects up to 154.3 pounds or 70 kilograms, which is roughly equivalent to what a compact car engine weighs or what an average adult weighs on Earth. If we wanted to make the most of our strength, we could also effortlessly lift objects that would be impossible here on Earth. Imagine being able to raise your parents with just one hand. Venus things would resemble Earth much more closely on Venus. As you can see, Venus has a gravitational attraction that is extremely similar to the Earth at 8.87 meters per square second. A person weighing 150 pounds or 68 kilograms on Earth would weigh 134.9 pounds or 61.2 kilograms on Venus. However, this figure is misleading because, although our weight will decrease slightly, we will not be lighter on Venus. On the contrary, we will barely be able to move a finger. Even though Venus' gravitational pull force is weaker, the atmosphere is much heavier and denser than on Earth. Have you tried swimming to the bottom of a pool? If you have attempted, you would know that as you go closer to the bottom, the pressure on your body begins to feel more and more. This is because the more you dive, the more significant amount of water is concentrated on top of you, and this water generates pressure in your body. This is exactly what the atmosphere does. Although it may not seem like it at this moment, while you watch this video, you are submerged in an ocean of air. The air you breathe that makes up the environment is a substance that weighs, and that weight is always on you, only you do not recognize it since all your life you have felt it, and your body is acclimated to it. But if we removed all the air from the atmosphere, your body would suddenly begin to swell like a balloon because you would lose pressure. Humans are accustomed to this pressure. If it is removed, we will perish. This is what is known as atmospheric pressure. The more gas molecules in the air, the heavier it will be, and the heavier it is, the greater the pressure we will feel. On Earth, the atmospheric pressure is measured in pascals and bars. The atmospheric pressure on Earth is only 0.00101 bars, while on Venus, the atmospheric pressure is 90 bars, similar to diving kilometer deep into the ocean. Because of this, even if the force of gravitational attraction on Venus is less than on Earth, atmospheric pressure would crush our bodies like tortillas, preventing us from lifting a single finger. Mars on the red planet, things would be very similar to Mercury because, on Mars, the gravitational pull force is 3.71 meters per square second. Because of this, a human weighing 150 pounds or 68 kilograms on Earth would weigh 56.6 pounds or 25.7 kilograms on Mars, pretty much the same as Mercury, except for small and substantial deviations. Mars is much further away from the Sun than Mercury, and unlike Mercury, which has no atmosphere to shield its surface from wind and solar flares, Mars has an atmosphere that shields it from solar radiation. As a result, Mars experiences enormous sandstorms occasionally and has days that are remarkably comparable to those on Earth. These elements would make it difficult for someone to lift objects on Mars if there is a lot of wind present. The low temperatures may also make it difficult for people wearing spacesuits to move around. But assuming people manage to build cities to protect themselves from sandstorms and wind, a healthy person would be able to lift objects to 155 pounds or 70 kilograms and jump slightly higher than on the Earth with heights of 4.2 feet or 1.3 meter. Jupiter, we enter the heavyweights. As anticipated, the largest planet of them all also has a powerful 24.79 meters per square second gravitational pull. This causes things to weigh much more on Jupiter than on Earth. A 150 pounds or 68 kilograms adult would weigh 382.2 pounds on Jupiter or 173.3 kilograms. This is more than double what it weighs on Earth. Simply that weight on top of us would be enough to keep us tied to the ground or the surface of a spaceship or space station floating in the clouds of the gas giant. Jupiter's gravitational pull force wouldn't allow us to do many things. Even something as simple as leaping would cost us a lot of work, reaching maximum heights of just 0.6 feet or 0.2 meter. Without a doubt, our bodies could not endure being subjected to Jupiter's gravitational pull for an extended period of time. If we were lucky, the only weight we could lift would be our own bodies. Saturn, we will eventually arrive at Saturn once we have escaped Jupiter's crushing gravitational pull. In this instance, things get calmer since the force of gravity of Saturn is 10.44 meter per second square. As you can see, Saturn has a gravitational pull that is very similar to that of the Earth despite being significantly larger. This is due to the makeup of the planet. Remember that unlike the Earth, which is mostly made of rock and occupies little space, giant planets are mostly made of gas. Gases, on the other hand, are both very light and take up a lot of space. Because of this, except for Jupiter, the rest of the gaseous planets, although they are larger than the Earth, the force of gravity is not so different. On Saturn, a 150 pounds or 68 kilograms adult would only weigh 158.9 pounds or 72 kilograms. As you can see, the difference would not be so significant, but our weight would increase, so our ability to carry things on top of it, like on the moon, instead of increasing, would be reduced. The most we could haul would be things weighing less than 25 kilograms or 55 pounds, like boxes, tools, or kids who needed help getting around. Uranus, we continue through the gaseous planets and reach Uranus. This planet has a gravitational pull force of 8.87 meters per square second. Sound familiar? Exactly. What happens is that the force of gravity on Uranus is precisely the same as on Venus. A person weighing 150 pounds or 68 kilograms on Earth would weigh as little as 131.9 pounds or 59 kilograms on Uranus. This would improve our strength if we were in a spaceship or a hotel that floated over Uranus clouds. We would feel lighter, being able to jump up to 1.96 feet or 0.6 meter and lift objects slightly heavier than we can lift on Earth, such as a car tire weighing 68 pounds or 31 kilograms, or heavy tools than on Earth would cost us some work to hoist. Neptune, we arrive at the most distant and chilly planet. In Neptune, the force of gravitational attraction is 11.15 meter per second square. As a result, a person who weighs 150 pounds or 68 kilograms on Earth would weigh 169.4 pounds or 76.8 kilograms on Neptune. The gravitational pull force of Neptune is greater than that on Earth. Because of this, our ability to lift heavy objects would be diminished as we would use some of our strength to hold our extra weight. Because of this, we would not be able to lift anything heavier than a travel backpack, which weighs 48.5 pounds or 22 kilograms on Neptune. In addition, the highest we could jump is 1.31 feet with the additional weight on our bodies, or 0.4 m. Finally, let's talk about a body that is not a planet but worth mentioning. We talk about Pluto, the dwarf planet. On Pluto, the gravitational pull force is only 0.62 meters per square second. This represents a small fraction of the Earth's gravity. A person weighing 150 or 68 kilograms on Earth would only weigh 9.9 pounds or 4.5 kilograms on Pluto due to this body's weak gravitational field. Due to this, a human on Pluto could move objects weighing up to 881 pounds or 400 kilograms. This is more or less what a compact car or a cow weighs. With our lightweight, we could also jump up to 25 feet or 7.6 meter, which, when compared to the height of a two-story house on Earth, would take just one impulse from our legs. How weight acts on the different planets of the solar system is fascinating. Would you like us to present more fascinating solar system related information? Comment below with your thoughts and let us know.